Hello. Let's derive the velocity of a particle which is freely falling under gravitational force at a particular time t, or we can say so. I mean, let's calculate this terminal velocity. Right? Let's say, let me write it down. Free falling object. Right? I mean, with air resistance. Right? If if a body A of mass m is falling under gravitational force, then the only force which is acting on it is gravitational force, right? Which is Fg is mass times acceleration if there is no air resistance, right? No air resistance. If there is an external force, I mean the force which resists its motion, then we need to add an equation of motion. This will not be the case. I mean, this is what will be this simpler, right? As you can see, in the case of uh, resistance force, it will be dv by dt equal to g, right? From this, as you can simply hear, Fg equal to ma, right? Ma equal to Fg is gravitation force acting, it is g, right? Get cancelled. A is dv by dt, which is equal to g, which is what I have written. But in the case of air resistance, there will be some force which is opposite, right? Which will take it as minus, and you can make some rough guess that force acting is inverse directly proportional to the velocity of the body, right? It will be v, and let's say some constant to match the dimensions, right? Then it will be dv by dt equal to g minus alpha v, right? You can write it as dv by dt plus alpha v equal to g, right? This looks like a differential equation, which is dv by dx plus p of x into y equal to q of x, which we have solutions for this very readily available. We just need to multiply with integrating factor. Let's say it's mu of x. The formula for this is e power integral p of x dx. Here in our case, y is v, right? X is t, alpha is p of x, g is q of x, right? Then integrating factor in our case is mu of x equal to e power integral of alpha into dx. Oh, sorry, dx, right? X case is, in our case it's t, right? Alpha into dt. Because alpha is not a function of t, we can move it out. Then integral of dt is t. This is integrating factor. Then multiply this integrative factor to the differential equation, which is dv by dt e power alpha t into dv by dt, right? Plus alpha e power alpha t into v equal to g into e power alpha t. As you can see, this equation can be written as d by dt of e power alpha t into v, right? Which is equal to g into e power alpha t. If you integrate on both the sides, right? If you integrate on both the sides, it will be e power alpha t with respect to 2. It will be e power alpha t into v equal to g into e power alpha t by alpha plus some initial conditions c, which will determine the value of c, right? It will be then g by alpha e power alpha t plus gc. Then v equal to, if you divide e power alpha t in both sides, it will be g by alpha plus gc into e power minus alpha t. All right, this will be fine. Then let's take some initial conditions to know the value of c. Let's say that at time t we have a dropped initial velocity of u equal to 0. That means it's freely falling, right? Freely falling object, then it will be v velocity of time t equal to 0 is 0. Then this will be, as v is a function of t, this will be at time t equal to 0, this will be g. This will be g by alpha plus gc into e power 0, which is 1, right? G by alpha plus gc equal to 0. Then gg will also go, then c equal to minus 1 by alpha. So the equation is v equal to g by alpha plus g into c is minus 1 by alpha e power minus alpha t, which is, you can write it as g by alpha is common, then it will be 1 minus e power minus alpha t, right? That is v equal to g by alpha into 1 minus e power minus alpha t. As you know, at terminal velocity, the both the forces, I mean at terminal velocity, this is falling, right? And this force, resistance force and gravitational force. At terminal velocity, both these forces get equal, right? Then net force equal to Fg minus Fr, right? This will get equal, then this will become 0. Then m into dv by dt becomes 0. If this is 0, then v becomes constant, right? Then terminal velocity means it will reach, I mean, a speed of constant speed, right? You can see, directly see, as if as t tends to infinity at a particular time, then v will be g by alpha into 1 minus 0, right? Which is equal to g by alpha. So it will reach a terminal velocity of g by alpha.